Hello viewers, in today's class we are going to discuss a very important and conceptual problem from definite integrals, right? So here we have to solve a very interesting problem, and the problem goes like this. If f of x is equal to x plus sine x, then we have to find the value of this integral, that is from pi to 2 pi f inverse of x, right? So here f inverse of x is the inverse of this function f of x, and we have to calculate the value of this integral, in which the integrand is the inverse of the given function f of x, right? So let us start. Now let us first take this integral as I, right? So I is pi to 2 pi, and we have f inverse of x dx. So in order to solve this integral, we'll make use of the concept of integration by parts, right? And let us first take f inverse of x is equal to y, right? So we'll assume that the inverse of f is equal to y, so that we can write x is equal to f of y, right? Okay, so once we have taken f inverse of x is equal to y, we have x is equal to f of y. Now differentiating both sides with respect to y, right? So what we will we'll get dx over dy is equal to d by dy of f of y, right? So first we will differentiate this function f of y, and the derivative is simply f prime of y, right? So dx can now be written as f prime of y and dy, right? So we have got the value of dx in terms of y, right? Now let us change the limits. So here the limits vary from pi to 2 pi, that is x is equal to pi and x is equal to 2 pi. So we have to find the value of y when x is equal to pi, and when x is equal to 2 pi, what is the value of y. So now when x is equal to pi, let us substitute this value in this function, right? And see what we get. So we'll get f of pi is equal to pi plus sine pi, and the value of sine pi is 0. So we have pi plus 0 is equal to pi, right? So now we have f of pi is equal to pi, and this implies that because we have x is equal to f of y, so when we put here if we write pi is equal to f inverse of pi, then if we compare this expression with this expression, that is f inverse of y is equal to y, sorry, here we'll have x. So when we compare this expression with this one, then we see that x is equal to pi and y is equal to pi, right? So when x is equal to pi, then obviously y is equal to pi, right? Similarly, when x is equal to 2 pi, let us substitute it over here. We'll get f of 2 pi is equal to 2 pi plus sine of 2 pi, and sine of 2 pi is 0, so we'll have 2 pi plus 0, that is equal to 2 pi, right? So we have f of 2 pi is equal to 2 pi, and this expression can be written as 2 pi is equal to f inverse of 2 pi, right? And again if we compare this expression with this one, then we have y is equal to f inverse of x, right? And if we compare these two expressions, then we'll get y is equal to 2 pi when x is equal to 2 pi, right? So y is equal to 2 pi when x is equal to 2 pi, right? So now we can express this integral I as integral from pi to 2 pi. Here we have y is equal to pi, here we'll have y is equal to 2 pi, and for f inverse of x we can write y, and for dx we can write f prime of y dy, right? So now we have to evaluate this definite integral, right? So our integral is now reduced to in terms of y, and our integrand is y times f prime of y, right? So we have to evaluate this definite integral, but in order to evaluate this definite integral, we'll first find the indefinite integral, right? And then we'll apply the limits, right? So we'll find the integral y times f prime of y dy, right? And this integral can be evaluated by the method of parts. So now let us evaluate this integral by method of parts, and let us call this integral as I1, right? So I1 is integral y f prime of y dy, right? And the formula for integration by parts, it goes like this: integral of uv dy, right? If we have two functions u and v, which are functions of y, and if we take u as the first function and v as the second function, then we can write the integral of the product of u and v as u integral of v, then minus integral derivative of u with respect to y, then integral of v with respect to y, and the integral of this entire term, right? So here we'll have dy, right? So what we will do, we'll take this function as u and this function as v, right? So our u is y and v is the derivative of f with respect to y, right? So we'll substitute the value of u and v in this formula. So now I1 is equal to u is y, then integral of v, that is f prime of y dy, minus integral of the derivative of u, and u is y, so here we'll have y, then integral of v, and v is f prime of y and dy, and here we'll have dy, right? So we have substituted the values of u and v in this formula, and we have got this expression, right? Okay. So now we see that the integral of f prime of y dy can be written as integral of the derivative of f of y and dy, right? So this expression can be written like this, because for f prime of y we have written a df over dy, right? So the integral, this integral is equal to simply integral d of f of y, so we can write it like this: f of y, right? So here we have y times f of y minus integral derivative of y with respect to y is 1, and integral of f prime of y dy is equal to f of y dy, right? So now we have got this expression. So I1 can now be written as y f of y minus integral f of y dy, and for f of y we can find out f of y from this expression. So replacing x by y here, we'll get y plus sine of y, right? Okay, so now I1 is y For f of y, we can write y plus sine of y minus, and here the integral of y is y square over 2, and integral of sine y is minus cos of y, right? So here we are not writing the constant of integration because we have to finally substitute the limits, so we'll ignore it. So we have I1 is equal to y square plus y sine y minus y square over 2 plus cosine of y, right? So these two are like terms, so we have I1 is equal to 2y square minus y square is y square over 2 plus y sine y plus cos of y, right? So now we have got the indefinite integral I1 as y square over 2 plus y sine y plus cos y, right? So now let us write I as I1, and the limits are from pi to 2 pi, right? So I1 is y square over 2 plus y sine y plus cos of y, and the limits are from pi to 2 pi, right? So now first we'll take y is equal to 2 pi, and then we'll take pi, and then we'll take the difference, right? So here we have y is equal to 2 pi, so 2 pi square is 4 pi square over 2, and here we have 2 pi sine 2 pi plus cos of 2 pi, right? And minus when we'll take y is equal to pi here, so we'll get pi square over 2 plus pi sine pi plus cos of pi, right? So now we have to evaluate this expression and this expression, and we'll take the difference. So now we know that the value of sine 2 pi is 0, because sine n pi is always equal to 0 whenever n belongs to the set of integers, right? And this value is also 0, this value is 0, and cos of 2 pi is equal to 1, and cos of pi is equal to minus 1, right? So here we'll have 1, and here we will have minus 1. So now we can write I as this is 2 to the 4, so we have 2 pi square plus 2 pi times 0, this term, plus we have 1, and then we have minus this is pi square over 2, and then we have pi times 0, and cos pi is minus 1, right? So we have 2 pi square, this is plus 1, and here we have minus pi square over 2, and this is minus 1. So this is 2 pi square plus 1 minus pi square over 2 plus 1, and this is 4 pi square minus pi square over 2, and 1 plus 1 is 2. So we have 3 pi square over 2 plus 2, right? Or we can also write it as 3 pi square plus 4 over 2, right? So viewers, the value of this integral is equal to 3 pi square plus 4 over 2, right? So this is how we can solve this type of problems.